Now the output for a within groups Anova looks like this. General linear model, that's what you've done. It reminds you of the three levels of your variable. So 1, 2, 3, cheese, furniture, places. You have a table of descriptive statistics. Then the next table you need to look at, just skip past these ones, is the one called tests of within subjects effects. Now this is quite a complicated looking table because there's all these different rows in it, but basically you just need to look at the top row. Stimulus type, that's the name of the independent variable, so this is the effect, and this is the error variance, that is the variance caused by things that aren't the independent variable. So we just need to scroll along here. Here's your significance level. It says 0.000. Now, as we know, you can't have a probability of exactly 0, so this must be a rounding error. And I'm just going to show you a little trick in SPSS. If we click in this table and then double click on this value here, see, the table will open up. So if we double click into this value here, it tells us that the value is actually 4.8047 and so on and so on. It says E minus 33. Now what that means is you'd have to take the decimal point and move it 33 places to the left. So this means that the significance level is actually 0.0000000 and so on and so on and so on. There were 32 zeros after the decimal point. Then it says 4.8. Now we wouldn't report that. We wouldn't say P equals and then write out 32 zeros. So we'd say in this case that P is less than 0.01 because it is. Okay, so I'll just close that down again. So that's the significance. So we have a significant ANOVA overall. So the independent variable is having an effect on the dependent variable. In the next column you have partial eta squared. This is the effect size. 0.77 is a medium to large effect size. So there's pretty big effect overall. So not only is it significant, it's large in its magnitude. And then the right hand then you have the observed power. Now observed power can be very misleading when you have a significant result, because power is your ability to detect an effect, if there is one. Now if you have detected one, because there was one, then it will tell you that your observed power is very high because you detected something. So it's telling you basically you found something, therefore you must have had a good chance of finding it. So observed power actually becomes much more important with non-significant results, and then you can consider why the power of your experiment was low if it comes out to be non-significant with low power. Okay, so that tells us that we have an overall significant effect. It doesn't necessarily tell us, it doesn't necessarily follow that each of the three levels of the variable are different from each other. We know that the smallest one is different from the biggest one, but we don't know about the one in the middle.